As a cargo operator, always remember the maxim, at no time shall there be a flammable atmosphere during cargo operations. Now, let us study the relationship between composition and flammability of mixtures of methane, oxygen and nitrogen. Make a note of the identified points in the flammability diagram as they define its boundaries. The diagram is segregated based on the behavior of the mixture. This diagram assumes complete mixing, which in practice may not occur. The axis AB represents oxygen-nitrogen mixtures with no methane present. Here, point A represents 0% oxygen and 100% nitrogen, while point B represents 21% oxygen and 79% nitrogen. The axis AC represents methane-nitrogen mixtures with no oxygen present. Here, point C represents 100% methane and 0% nitrogen. Mixtures of air and methane cannot be produced above line BC. Any point within the triangle ABC represents a specific proportion of methane, oxygen and nitrogen in the mixture. The diagram is divided into zones based on the behavior of the mixture. The flammable zone is determined by the upper and lower flammable limits of methane. During cargo operations, it should be ensured that mixtures in this area should be avoided at all times. Area EDF represents the flammable zone. In area HDFC, although a flammable mixture may be formed, it contains too much methane to ignite. Area ABEDH is safe as a flammable mixture cannot be formed when mixed with air. LNG cargo operations such as inerting and aerating, where the cargo tank atmosphere changes, are very critical. You will now study how precautions are taken during these operations to prevent the formation of a flammable atmosphere. When preparing for first loading after dry docking, the cargo tanks on an LNG carrier have to be inerted prior to cool down. In this example, we will consider inerting using nitrogen. In practice, inert gas is used as it is less expensive. By inerting, the tank atmosphere is maintained in such a way that even when methane is loaded, the mixture will never fall in the flammable zone. Thus, the normal procedure adopted for avoiding flammable mixtures in cargo tanks and piping containing air is inerting with nitrogen before admitting methane until all sampling points indicate 5% or less oxygen content. Assume that the tank is initially full of air at point B. Nitrogen is added until the oxygen content is reduced to 13% at point G. Addition of methane will cause the mixture composition to change along the line GDC. Note that it does not pass through the flammable zone but is tangential to it at point D. If the oxygen content is reduced to any point between 0% and 13%, that is, between points A and G, the change in composition with the addition of methane will not pass through the flammable zone. Theoretically, when inerting, it is only necessary to add nitrogen to air until the oxygen content is reduced to 13%. However, in practice, as complete mixing of air may not occur, the oxygen content is reduced to 5%. Before dry docking, the cargo tanks on an LNG carrier have to be inerted and then aerated. In this example, we will consider again inerting using nitrogen, although inert gas is used in practice. By inerting, the tank atmosphere is maintained in such a way that even when dry air is added, the mixture will never fall in the flammable zone. Thus, the normal procedure adopted for avoiding flammable mixtures in cargo tanks and piping containing methane is inerting with nitrogen before admitting air until all sampling points indicate 5% methane. Assume the nitrogen is added to the tank containing methane at point C until the methane content is reduced to 14% at point H. As air is added, the mixture composition will change along the line HDB, which is tangential at D to the flammable zone but does not pass through it. As complete mixing of methane and nitrogen may not occur in practice, when inerting a tank full of methane, it is necessary to go well below the theoretical figure 14% to a methane content of 5%. The flammable range is the area between the minimum and maximum concentration of the vapor in air, which forms the flammable mixture. It provides an estimate of the ratio of flammable vapor to air required for combustion to occur. Flammable or explosive limits of gas mixtures change with temperature, pressure and concentration. The auto-ignition temperature is the lowest temperature to which the gas needs to be heated to cause self-sustained combustion without ignition spark or flame. It is not related to the vapor pressure or the flash point of the substance. As the source of ignition is often external flames or sparks, the flash point rather than the AIT is used for flammability classifications. However, AIT is important when considering accidental release of the vapor on hot surfaces.